Okay, good morning. So I'm Michael Bright. I'm going to talk to you about serverless Python. So just very briefly about myself. I live in Grenoble. I've been living there for a long time now, 26 years. I recently set up as a trainer around cloud native, Docker, Kubernetes, that sort of thing. I also run a Python and Docker meetup group in Grenoble. So basically, if you're interested in training wherever, I'm your man. And if you are interested in talking about Python or Docker in Grenoble, I'm interested to hear from you as well. So thanks for coming. This is what I propose to talk about. Very brief introduction about what is serverless. Looking at then the offerings from the different cloud providers, so the main four. Look at some of the open source tooling, and in particular I would just briefly look at Chalice, which is an open source project from AWS to access their AWS Lambda platform. I'll then look at the different open source platforms we can use to set up our own serverless platform on-premise. And in particular I will look at OpenFast, something that came out of the Docker community, which has a really strong community around it. So I will demo both Chalice and OpenFast. So what is serverless? So does it mean no more servers? Of course not. It's really about removing that responsibility of administration of servers and so on from the developer. The developer just focuses on his business logic. Okay. Anyway, it's sort of, I see it as the ultimate cloud native. As you look at evolution from bare metal to virtual machines to cloud, we're getting to more and more agile deployment and development paradigms. And serverless is really getting to what is probably the ultimate, where you're just providing functions to a platform, and those functions will be triggered based on some events. Serverless, those who don't like the name, personally I like it. I think it speaks very well about what it's about. You should know that it's essentially two things. Fast, so functions as a service. It's the developer writing his functions and loading them up into the platform that I mentioned. And it's backends as a service. So, if we're just selling just deployment of functions, that wouldn't be very interesting for Amazon, for example. It would cannibalize their VMs business, which is doing very nicely. But in fact, Amazon, they realized that most of the VMs that people were deploying in EC2 were actually using a lot of their back-end services. You're probably aware that Amazon Web Services, they have hundreds of services available, different databases, and notification systems, SMS, etc. So function as service is really about gluing together back-end functionalities to create an overall service. So as I've said, serverless is a paradigm. It's also a company that I don't like. Serverless.com is a company that produces some open source tools that facilitate working with serverless platforms. It's a pretty good tool. I just regret that they stole the name serverless for the company. But okay. So as I said, serverless, it's about allowing developers to focus on their business logic, focus on their apps. They no longer have to worry about provisioning a server, maintaining it, make sure that it's patched and so on, whether it's developer or an operator, or about auto-scaling in function based on the demand coming through the network. Now it is the cloud or platform provider who has that responsibility. Okay. It's a platform which is pretty well pay-as-you-go. So first of all, these platforms are available. They tend to provide something like 1 million requests for free per month, which sounds a lot, but of course there is a cost when you go beyond that, and you have to be careful if your serverless application has a lot of success, if it goes viral. There have been some bad experiences from people there. But nevertheless, The initial investment is minimal. You don't have any CapEx or OpEx investment, no servers, no initial payment. So it's really great for innovating. You can really experiment. 1 million requests to get started in a month is quite a lot. So that allows short time to market, enables innovation, and you could also just, these platforms generally have an on-premise version that you can use. With Lambda, we'll see how we can develop locally without any costs on the AWS platform itself. Azure Functions as well has a local version. Okay, as I already mentioned, I see it as a continuum from bare metal, virtual machines, say cloud here, containers, and then serverless. It's really just about providing these functions, which obviously are very lightweight, very quick to spin up, and a natural evolution of the cloud. Serverless, it's an inherently event-driven architecture. So again, we have a developer uploading his code here. You'll have some sort of API gateway, which is going to allow external access to your functions. And that's one source of services that you might have to pay for from your service provider. So the events could be just GET requests, REST requests from a browser or some command line client. They could be webhooks from something like Docker Hub or GitHub, which, when you do a commit of some code, it's going to launch a function in your service. Or it could be something scheduled, something on a sort of a cron basis. And as I mentioned, that's pretty well the front end of it. But for these things to be really interesting, then you need something else. It could be actually sending events out into some of the systems. It could be invoking other functions, but typically you're going to be using some sort of back-end service. They don't need to be in the same provider. So people might make the criticism that AWS Lambda, for example, there's a lot of lock-in. That lock-in is something that a developer chooses. There's nothing that restricts you to using just Amazon's back-end services. Okay, so if we look at the different cloud providers, so here I'm looking at the main 4. There are others, but we know generally anyway these are the main cloud providers today. So AWS Lambda, Amazon are the ones who launched, serverless, the concept has existed for 10, maybe 15 years. But it's when Amazon launched Lambda in a beta form at the end of 2014 that suddenly there was a real uptake in interest. And it's a paradigm which really is having enormous success today. Then the other providers, basically Microsoft with Azure, Google, GCF, and IBM, also have interesting offerings. But it's still pretty well Lambda, which has the main mindset today. In terms of service provider offerings, we'll look later at platforms where we can implement that ourselves on-premise. So as I say, it's introduced late 2014, so a reInvent, in fact, in November 2014. It was pretty much in an alpha form at the time, but now is a year later, it was already pretty well ready for production, and now there are many people using that in production. I'd say the main languages used are Node.js and Python, but there are other languages, Java 8, C#, and so on. And more recently, they introduced Go and C#.NET reInvent last year. As I mentioned, there's 1 million requests a month which are free, and then there's what seems like a minimal amount for following requests, but of course that adds up pretty quickly when you're beyond 1 million requests. Azure, so Microsoft introduced Azure Functions in 2016. What's interesting about Azure is that I think it's the one with the most sort of complete dashboard. As you can expect, I mean, whatever you might like or dislike about Microsoft, they have an incredible experience in developer tools. They support a number of languages. Again, JavaScript, Python are probably the main ones used, but well, C# as well. And there is an open source runtime for Azure Functions, so you won't get all the nice sort of Azure portal interface, but it means that you could deploy your functions locally, at least for testing. And then they have some excellent developer tools around that. Google, I'm never too sure what to say about Google. I never find them that serious in serverless. That said, about 6 months, 6 months ago now, they released a project called Knative, which isn't a serverless platform in itself. It's a sort of abstraction layer for implementing serverless platforms above Kubernetes. So at least at that level, it's something they're really taking seriously. And interesting, okay, they support Node.js or JavaScript and Python, only in beta. I didn't check back again. A month ago, if I remember correctly, they still weren't supporting Go, which seems a bit surprising. IBM is an interesting one. I used to say it was the only one that was open source. I didn't realize that Azure Functions had an open source version as well. They created an internal platform, OpenWhisk, which they later contributed to the Apache Foundation. So they provide a bit of the usual sort of runtimes, JavaScript, Python, Java, Go even. There's also one which is a bit surprising, which is Swift, the language from Apple. Apparently they got some sort of involvement with some developers who really needed that. I mean, companies who really needed that. So it's interesting that there is a fully fledged Apache project behind that one. And then there are others such as Oracle, for example, which I haven't included here. Just to give you an idea, I mean, I'm not going to go into detail on this, but this is just an example of something called Smart News, just to show you that in here, in fact, we're using a lot of Amazon services, S3, EMR, Kinesis, DynamoDB, SNS, yeah. The Lambda part is actually just a small part of that overall application. So just to underline that, you know, functions as a service is just the glue, or at least one part of the glue between all the elements of an overall solution. If we compare, the only thing I really want to pull out here is comparing the big four platform providers, just to compare where they differ. It's in particular around the API gateway. So IBM Cloud Functions, it's called now. It's no longer OpenWhisk. The usage of the API gateway, which provides external access into your serverless functions, is free. Same for Azure Functions. Whereas Lambda has quite a hefty cost, $3.50 for 1 million calls, and about the same for Google Cloud. So you just have to be aware of the hidden costs of serverless. Some people have been bitten. It's worth mentioning, so I've said that Azure Functions is open source, and obviously Apache OpenWhisk is. But until now, there have been a lot of proprietary platforms, or even these open source platforms. They don't use the same terminology or the same definition of events. So it's pretty interesting that I think about a year ago, Cloud Native Computing Foundation created a serverless working group. And so they're working on white papers around the serverless space, trying to ensure that there is common terminology. And then following on from that, so as I mentioned, Google released this year Knative. So it's just a layer that would go above a Kubernetes platform. In fact, Kubernetes and Istio, a service mesh, that will facilitate creation of serverless frameworks above Kubernetes. So things like orchestrating builds of container. Something I didn't mention is generally all these serverless platforms use containers under the hood. So one of the things Knative provides is just a way of orchestrating builds from source code to those containers. Particularly it's built upon Kubernetes and Istio, so it's providing service mesh, traffic management type of facilities and platform logging. So it's just avoiding that each serverless platform provider reinvents the wheel. Okay, so I talked about the offerings from the cloud providers. I want to talk briefly about open source tooling, and in particular about Chalice, which is an open source project from Amazon. So I mentioned Serverless.com. It's a company that does, in fact, it's Node.js application which facilitates deploying to different serverless platforms. Most of these platforms, it's like the number one target is always Lambda because there's so much that is deployed onto Lambda. But they are targeting other platforms like Azure, IBM Cloud Functions, and so on. And so it basically gives you one tool. You'll use the same commands to deploy to the different clouds. Okay, today the code is going to be quite different between those different systems, but at least the deployment process is going to be common. There are platforms like Zapper, quite similar to Chalice. So Chalice basically just provides a simple way of creating Flask-like applications that you can then deploy into Lambda or test them locally. Zapper provides the same sort of functionality for Flask-like, but also Django applications. Okay, so with Serverless.com, these are just some of the platforms that they support. Some of the big cloud providers and some open source serverless platforms. Okay, that's where I wanted to get to. Not just the image, though I do love the image. It takes me back to my childhood. Okay, I really want to get to Chalice, and I want to show what that's about. Again, that's 4 frameworks that work with Python and Lambda in particular. Some of them try to be multi-language, multi-platform, but generally it's Python and it's Lambda, which are the principal targets. Okay, so I've installed Chalice. Chalice is a fairly simple install. I mean, I'd recommend creating a virtual environment. So I've already sourced my virtual environment here. And it's a simple pip install Chalice. Can't do much simpler than that to install. Let me just see where I am. Okay. Okay, so I want to start here. I want to create a new project. It's as simple as Chalice new project. Let's call it live demo. It's created me a template for an application. Very simple. We can see it's Flask-like. Just a basic root decorator. I go to my other window. I go into that same directory and I just do Chalice local. It's going to start up a web server. I'll switch back again. If I do HTTP, and so remember we have just this simple root and it's going to return us some hello world. That moved permanently, brilliant. Okay. Thank you. Thankfully, someone's awake. Okay. And I somewhere have a canned demo. Almost as simple So in this example, I have the same hello world on slash. I have a root slash test, and I have another root slash cities with a parameter. Okay, nothing amazing. What I wanted to show was when I copied that app.py in there, the server automatically detected that the source had changed, and so restarted the development server. So there's nothing to do. So obviously we have the same hello world, especially if I get the port right, which is good. The slash test. Okay. And then there was, in that app.py, there was just a dictionary with 2 cities in there, Seattle and, I can't remember the other one. So I make my request. Okay, we get the result that Seattle is in Washington. Okay. Very simple examples. So I just want to show how simple it is to use. Similarly, I can do a chalice deploy. So instead of just testing it locally, that has been pushed out to Lambda. By default, it's pushed it out as live demo, name of my project, -dev. And here we have the address of that alive. Okay. We see just that it's been rerouted. There is a /API /cities and so on, but otherwise it's exactly the same interface. Okay. Okay, that's all I wanted to show around Chalice, because I really want to move on to OpenFaaS. So just underlining again, it's an open source project on GitHub, and it's a project which is created by Amazon. So even though Lambda itself is not open source, there is some open source tooling around that. Oh, okay. Been there, done that. Okay, so I wanted to look at the open source platforms. We've looked so far at what the cloud service providers provide. Just check something. Okay. So there are a number of open source platforms for serverless that you can deploy yourself, or you can deploy out in the cloud. Mainly they work on Kubernetes. So you can tell already Kubeless, guess what platform that runs on. In fact, Kubeless, Fission, Apache OpenWhisk, Nucleo, I think, and I think Spring and FN, I think they all run on Kubernetes. I'm not sure if any of them, apart from OpenFaaS, actually run on Docker Swarm. So, okay, Kubeless is a project essentially from Bitnami. There are a lot of these projects. This FN project is currently managed by Oracle. It was actually a fork, I believe, from a company called Iron.io, who were quite instrumental in serverless probably about 10 years ago. Fission's from Platform 9, company to managed Kubernetes platforms, managed Kubernetes and managed OpenStack platforms. Nucleo is a small Israeli startup who they are focusing on data processing applications, and in particular getting minimum latency. I didn't talk about what type of applications are best suited to serverless. One thing is that it's best suited to applications where, I say, the peak of demand is unpredictable, or at least there are peaks in demand, and there might be heavy processing, but as well where you can wait the response. Latency would be typically 100 milliseconds minimum. Nucleo, so their focus is specifically on data streaming applications and getting that latency down to a minimum. So as I said, Apache OpenWhisk is from IBM. I've taken out the slides I had. Several of these platforms, like the cloud provider platforms, tend to provide just a subset of languages. Apache OpenWhisk and OpenFaaS allow you to bring your own container. In the case of OpenFaaS, that's particularly interesting. You can literally just wrap up a command line utility in a Docker file and deploy that as a serverless function. All of those are open source projects. Okay. So I really wanted to get to talk about OpenFaaS. So it's created by this guy, Alex Ellis, who's a Docker captain in the UK. He started that probably 18 months to 2 years ago. He's created an enormous community around that. It's probably, in my eyes, it's probably the platform that has the most grassroots innovation around it. As I mentioned, it's bring your own containers. There's a set of standard languages available and a set of templates for creating your own functions. There's a portal which has a function store, so we'll look at that in a moment. Command line tool, there's a flavor that runs on Kubernetes, where Docker Swarm was the original target. And it's very easy to get started. It integrates Prometheus for platform monitoring, and in particular, there's a newer project coming along, OpenFaaS Cloud. Essentially allows you to do GitOps. So when you submit code, it's going to be automatically built, and the latest version of your serverless function will be available. The overall architecture is like this. Your functions, or even command line tool, whatever, will be wrapped up in a watchdog, which is essentially just providing a local HTTP interface around the function, and maybe doing some restarts if necessary. The API gateway is also providing an HTTP interface, but to the exterior, and it will be responsible for scaling up functions if need be, if there's a lot of charge from the network, or even scaling them down to zero if there's zero charge. Okay. An example which was shown at DockerCon a year ago was an example of colorizing video. In fact, it was, strictly speaking, it was using machine learning scikit-image to do automated colorization of images, and then the video was just a matter of breaking a video down into a sequence of images, colorizing them, rebuilding a video from those. But it was just one example of some of the innovative solutions for serverless that have come from the community. Okay, so let's have a look at OpenFaaS. I'm running out of time, so I have to be quick. Oh yeah, hold on. So this is the portal. Let me enlarge that a little. I've pre-installed some functions. Some of them are some very basic ones provided by default, like word count, Markdown, base64. We can deploy new functions by going into the store. Some of the functions are available. So I've pre-installed this one, colorization. I'm going to just look at functions are available on my platform. Okay, we see the colorize is there. So just to show some examples of the command line tool, nothing amazing, just showing how it just facilitates some of the development. We can invoke a function directly from the command line tool, and it just operates on its standard in. So I have a test HTML with some Markdown in it. I'm going to invoke the Markdown function. Okay, it's converted our Markdown into HTML. Okay. Given the time, I'm going to go straight to a demo. Demonstrating the colorize application. So I have a script because there are a lot of complicated URLs and stuff, and it depends on visibility of IP address from within the Docker environment. So I've removed an image I have locally. I'm going to send a black and white image, which actually should be here. There you go. I'm going to send this image to that colorize function. So the function is using scikit image, and the function obviously is only as good as the machine learning, the training that's already been done. But there we have an example of the colorize function via OpenFaaS. Okay. Just I mentioned the OpenFaaS cloud. So the idea is, as you submit your development code into GitHub repo, a trigger is going to trigger an OpenFaaS cloud, and that's going to automatically build and deploy your functions into your serverless platform. So that's essentially the GitOps movement, which is coming along. So a few minutes. I wanted to show as well creating a new application. I was the FastCLI tool that I've used until now, listing functions and so on. I can use that as well to facilitate the building and deployment of functions. Unfortunately, in my Windows Cygwin environment, it doesn't work that well. So I've scripted it. I have a script which then calls a batch file. So I just do a bit of cleanup. Okay, so what's going to happen here is the command line tool FastCLI. I'll do a new project, Hello Pi, which I want to be in Python 3. It's going to scroll past very quickly. That's why I showed the command before. Okay, and so it's created here a directory. You can see that is the time now. It's really happening. It's created a template file, a manifest of what is in our function, and it's created a basic handler. Okay, so that's the template, telling it this is where our API gateway is, and we want to deploy this Hello Pi function, and this is the name of the image we'll use. I'll actually modify that one. That's the basic handler, just returns request. I'm going to copy in another one, which doesn't do much more, just at least gives us a bit of text with our request. And I need to just manually, oops. No, I'm just going to modify the manifest. So I will tag the image. So now we're going to build the image. It will be tagged with my name on Docker Hub. Okay, I won't show you the Docker file because we're running out of time, but basically it provides a template Docker file for creating Python functions. So it's now doing the build. Of course, I've done that all before, so the steps of the build are cached. And in fact, even the image itself, it's one I created yesterday. I'll do a push to the Docker Hub. Of course, again, the layers already exist because I put it there yesterday. And now I can deploy a new function to the gateway. Okay, and now when I list the functions, we now have this Hello Pi function. And I can do a request, which worked. Okay. Okay, I've taken 35 minutes. I'm going to stop there for